It's time for another rat run. I just found the actual line of these, all of the rat run puzzles, and there are 9 of them. And Simon is getting ahead of me. I haven't been recording these fast enough. He used to be just 1 puzzle ahead of me, but now he's 2.5 puzzles ahead of me. That's a fancy way of saying he's 3 puzzles ahead of me, but after I do this, he'll be 2 puzzles ahead of me. So that's 2.5. Okay. Oh, let's read this one. By the way, you can see I did puzzles, the Rat Runs 2 and 3 on this channel. 1 I did without recording, and then I realized it was good and decided to record the rest, but I don't have the first one. Anyway, Rat Run number 4, Borderline. Normal Sudoku rules apply. Place the digits 1 to 9, once in each row, column, and 3x3 box. We got that? Aim of experiment. Thinks the rat must reach the cupcake by finding a path through the maze without visiting any cell more than once, crossing itself, or passing through any thick maze walls. You can see a whole bunch of those. Those are easier to see than the Sudoku boxes. Diagonal moves are not possible in this maze. That is different. That might just be because I can only see part of the puzzle, but maybe there's just no possible place to move diagonally. Okay, black grunts. Why? I don't know why. I've never had a black grunt, so I don't know if I like those. But those are black dots that have a ratio of 1 to 2. I'm familiar with those. One-way doors. I believe these are going to be the 2 new things, or 3 new things after the diagonal moves thing. One-way doors. Things may only pass directly through a purple arrow if moving in the direction the arrow is pointing. And the arrow always points to the smaller of the 2 digits, so it's a greater than arrow. Or less than, depending on which. Yeah. Test constraint in this experiment. The correct path will be a valid region sum line. Those are interesting. So that means is the path he takes, she takes, or the path I take will have, will go through a whole bunch of the large 3x3 boxes, and that will divide it into regions which have the exact same sum. Before I start, I want to see if I can beat Simon on one of these, because he's been doing this a lot more than I have. But I mean, this is a rat run, so I should be better at him, and I very nearly did last time. So, let's squeak up. Squeak up. I think, yeah. Let's say that. Let's say that I'm squeaking up, and we are gonna start. It says resume. It doesn't say start because I quickly restarted, but I haven't looked at it yet. There is the rat. Okay. Region sums. So, yeah, I don't see anywhere he can, or she, or I can, go. Ooh, that's interesting. Okay, the region sum can be a minimum of 3 and a maximum of 17. Okay, well, let me put these 2 on the line. And whatever these 2 are, if it's like 2 and 3, for instance, then that means wherever I go, these 2 will have to, if I go this way, these 2 will have to sum up to 5, and these 3 will have to sum up to 5, and then if I did these 4, those would have to sum up to 5. I have a feeling this is going to be a bigger number. Okay. What is the shortest? Well, I can't go through there. What is the smallest number of cells I can visit in one particular box? If we could go this way, then that means 1, 2, 1, 2. Ew. Would that, if it goes back in the same box, what does that mean? Is it another region line? Or is it connected with that? I don't know. Okay, but that would be 2, 2, I'll say 1, 2, 2, for instance. But we're probably going to need a 3 and maybe even a 4. Maybe even a 5. If we go straight down, 3, 4. If I go 3 here, then I'm going to have to do 6 there. So let's not do 6. 3, 4. And 1, 2, which might be part of that again. I don't know. 1, 2. I'm going to need at least 4. So, if I do 4, if I go through 4 boxes, that's got to be at least 10, which means I can't ever do something like this one here, which is 1. So let me start writing some stuff. So if I go through 1 box in a cell, or 3 or 4 or 5, if I go through 1, the minimum I can have is 1. The maximum I can have is 9. I've already done this in my head, but I'm showing you guys. The minimum I can have in 2 boxes is 3, because that would be 2 plus 1. And then 8 plus 9 is 17. And then 1 plus 2 plus 3. And then 7 plus 8 plus 9. Oops. Okay. So anyway, if it was 6, the minimum would be 21. So I'll write it in just because I'm writing the others in. I'm not going to go to 7, 8, 9. But if Finks goes through 6 boxes, 6 cells in 1 box, it needs to be at least 21. And we already have a 2, which can only go to 7. So we can't have anything that does that. We also... well, no, I haven't proven that yet. I'm about to prove that. Hey. I've shown that Finks needs to go into a box of 4. So we're going to have 2s, 3s, and 4s. So we can't do any 1s. And 2, we're going to have at least 10, and then no more than 17. So right now our overall minimum is 10 and overall maximum is 17. Maybe we could do 5 boxes. 5 cells, rather. Anyway. Okay, I still have the same time. I accidentally exited out. But we're back with 6 minutes. Okay. So, there's a lot of stuff things could do in the first box. What about here? 3, 4, 5, 6. We can't do 1, 2, 3, 4, 5, 6. I believe we cannot go that way. Well, we can't connect this way because that would be 6 boxes. And we can't do this and then that because that's still 6 boxes. We could do this and then find a way all the way around. Okay. Well, I'm going to write down some stuff here. Can't go through those. We can't do this because that would be 1, 2, 3, 4, 5, 6. That would be 1, 2, 3, 4, 5. That's okay. Where can we go? Let me do a couple options. We can't go through here. Okay, so this... But I can't still say this is off the path. Because what if we go this way, and then 1, 2, 3, 4, we use that. What if we do that? Oh, I know what I can block. Oh, I think we have to. I'm assuming region sum lines. It's going to go back into this, so this would have to be 1. Just a 1 box here. So wherever I see going into, maybe that's the only place I see that, going into a cell for just 1 box, I can ignore that. That's rough because I'm not positive about that. I don't think I can go this way and do that and say that they're the same, that they're part of the same thing. I think they have to be separate. I'm going to assume they are separate. Let me read the rules one more time. I get to pause while I do this. That's nice. The box borders will divide the path into segments. It's not the segments are separate in each box. It's the path is divided into segments. So yes, I'm pretty sure, I'm like 98% sure, but I am going to mark that as being impossible, and that does start to give us something, because we're going to have to do that, because we can't go that way. So we'll have to go that way, because that would be 6. And then we have to do here, and we have to go there. Okay, so 2 and 4. Like I said, we need 2 and 4 at least. And then this, I mean, this could be anything. Not anything, but that's not useful yet, I don't think. I wonder if it goes all the way around here. One, 2, 3, 4, 5. And maybe I should do these slightly different colors. And that's green again, or blue, or whatever. I got to start here, but what happens? What happens next? I can still see a whole bunch of different ways it can go. Now, we can't go this way now, because we can't go through that way. We can't go through that way. Could go through that way. Between 10 and 17. If I can prove that somewhere we need to have 5. Oh, wait. So I said we can't go that way. And we can't do this. So we have to come down here. We also can't go around and do that because that's 6. So let's do that blue, I guess. We have to do that. 1, 2, 3, possibly 4. No. 1, 2, 3, 4, 5, 6. We can't do that. Okay, so this is 4. And this is 2. Okay. And we can't go up here. Jeez. Okay. We're getting this. Can't be 1. Then, okay, now we're getting somewhere. 1, 2, 3, 4, or 1, 2, 3, 4, 5, or 1, 2, 3, 4, 5. Or 1, 2, 3, 4, 5, and then that. 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2. So yeah, I haven't quite. I think it's likely we're going to get into a box of a segment of 5, but I can't prove that yet. Let's get rid of those. Come on. I'll do a couple different colors because why not? I don't know what I'm doing. I just saw that there was purple next to purple. Whoops. Purple. I need a fourth color. So this might be important. This column might be important. Okay, let's say it's 10. And that's let's say the division of the segments is 10 each. 10, 10, 10. That's 30. And then 15 can fit in there to get to 45. And we could have a 9 and 1 here, or an 8 and 2 and 7 and 3. Well, no, oh, this isn't 10. That's going to be the same here. If it's 10, then the most this could be is 7. 7 plus 10 is 17. 27. Is that... Yeah, that is one too much. Okay, so we can't have 10. Our minimum is now 11. And I think the exact same thing is happening here. So I'll... Yeah. Let me double check. This would be 10. This would be 10. This would have to be 1, 2, 3, 4. So the maximum is 3 and 4. So we got 10, 20, 23, 27. And then if you add 9, 36, and then you'd need another 9 for 45. Okay. So, what about if it's 17? 17 is 34. The smallest this could be is 37. And then we could have a 3 and a 5. But 5 couldn't make 17. Okay, so it can't be 17 either. All right, now we're at 16. Oops. Was that a 6? Oh, it was a 6, but my cursor was over it. Okay, 16 plus 16 is 32. Plus 1 is 33. 35. And 10. So yeah, we could have 197. I feel like that's still very constricted though. Well, it could be 792. Oops. Well, no, it'd have to be 3 because I'd have 1 and 2 here, so it'd have to be 3, 7, 9. Let's see if this is possible. 1, 2. It needs to be 17 total, so it could be a 6 and 8. Oh, ooh. All right. Is this what we're supposed to be doing? Is this the intended solve path, I wonder? Just figuring out. And maybe if we can prove that it can't be 15, then we can figure out the rest of the path too. But it's good I did it on this one instead of this. Well, I have to do it on this one because it also has, it's got 8 numbers here that I need to take care of. But let me explain that again. So if I try 16, 32, and I try to keep it as low as possible. And this is 33, this is 35. I've got 10 left, and I need to get a high number here to get to 16 here. So if I do a 3, that's the lowest I can use here. I'll get a 7. If I go any higher, if I go for a 4, then I get a 6. So this technically works, but then this does not, because I need to get to, because this is the black current, which means these have to be at a 1-to-2 ratio. Okay. I don't think I'm gonna, I don't know if I'm gonna beat Simon. I said I don't think I'm gonna be, but if I continue explaining everything, I won't. But 11 to 15. Okay. 15, 30. And then 33. This is going to be close. Let's start putting these in. 33. So I need 12. That's possible. Okay, so here, 15, 12, 4 and 8 do go to 12. Okay, so that is one possibility. I'm going to write that at the bottom here. 15 is a possibility. Let's just keep trying. Ah, that was bad. 14 is 28. And this would have to be 14. And I'm going to look a little more at this. So if this is 4 and 8, those are the highest numbers they could be and have a double. Then the smallest this could be is 15. So I'm not going to be able to use 4 and 8 again. If I use 9 here, and that is 10 and 12. Let's see if 12 works. 12, 24, 26, 27. All right, that's not good enough. But can I use 14? I couldn't do 13 because I'd need a 1 and a 3, and I already used a 3. All right, but 14. Okay, let me do no 12. I'll do this. This is no, this is yes. No, yes. No 12. Well, maybe it could still be 12 if it's 2, 4. I haven't checked that yet. So, I just know it can't be 3, 6, and that can't be part of 12. But 14. So this is 14, 28, 33, and then we need 12 again. I think that works. 7, 5, 9. It could be 8, 6, 7, 5, 9, 2, 3, and then this is a 9. Yeah, okay. So 14 also works. We're getting close. I think it was good to get those outer limits shrunk down, but I don't know if we can continue like this. I like starting with this instead, though. Can 4, 2 be part of 14 or 15? Actually, now I don't like doing this, but let's go 15, 15, and 9. And then it would have to be 6, like 1 and 5. Oh, 5 would have to be a 10 there. Okay, so it can't be part of 15. Let me draw this again. If it's 15, then I think we said that was 6, 8, 1, 2 for that particular segment. If it's 14, then we could go 3, 6, 1, 4. Okay, we're figuring out options. If it's 2, 4, it can't be 15, but if it's 14, then let's do like a 1 and 7. Okay, so 14, 28, 36. Well, my first thought is that gives me 2 2s there in this box, so that doesn't work. I haven't been paying attention to this box, but I don't think anything has mattered there. Although I think I sort of thought right here between these two was where the other box line was, because I was almost thinking about stuff there. There's a lot of stuff to think about, and maybe I'm too tired. I just did a different puzzle, and so this in particular won't work, but we could do 3, 5, and then this could be 9, and then this could be 6, 8. Okay. Oh, that's very interesting, though. Oh, that is a weird way to do this. This is 14, right? Yeah, I am doing 14s. 14. None of these three can be in that spot. So they have to be here, which means they have to be here. And this does not equal 9 plus 6 plus 8 does not equal 14. All right, I am just... I don't know if this is the way to do it, because it's quite bifurcated, but that is how I solve mazes. I made this point on a video I watched recently, but I made one of my rat mazes did get on Cracking the Cryptic, and I made a point in the comment that I kind of treated a bit more like a maze, where I try going left, that didn't work, I try going forward, that didn't work, I try going right. So I do try a bunch of options instead of going for a slightly more logical approach. But I think it is still a logical approach for that kind of puzzle, for the particular kind that I made. And here too, like trying this and seeing it doesn't work because it's 6, and this doesn't work because it's 6, for instance. That's what we're supposed to be looking for. So we need to be looking in the same kind of vein. All right. I think I'm doing this wrong. I don't like doing this now. I got distracted. Let's go back to 11, 12, 13, and we'll try 14 again, I guess. Okay, 11, 22. So the options I have are to put 8 here, 11, 22, 30, and then 9, 6, 5. Okay. With 11, I can do 1, 2, 3, 5. I don't think I can do a 2, 4. Because then, I can't make 11 here. Okay. So that is the only way to do 11. 12. I'm going to have to double check 14. But 12, 24. Let's try 1, 2. Oops. 36. 24 plus 9 is 33. And then 12. Yeah, it's 12 again. Yeah. Okay. And I used up my 6, so it's okay. That. Okay. 1, 2, 3, 6. And actually, I think I could do 1, 2, 4, 5 also. It's not shown here, so I'll move that around later. But yeah, I could do 4, 5 and then keep the 6 in here. Could I? Hang on. I need to get all of the high numbers in here. Okay, I could get 9, 2, 1, and then 7, 5. Okay, that does work. 4, 5. I don't know about this. 4, 5. Let's do 3, 9. If I do 4, 5, then there's 2 different 12s that need 3, 9, or 4, 8, or 5, 7, and I've used 4 and 5. So 3, 9 is the only option left. So, okay, that does not work. Okay. keep going. 2, 4. All right, and 12. So this would be 1 and 5. It would have to be 1 and 5. 12, 12, 24, 30, 15. Okay. Get rid of the 6. And could be a 4, 8. And then a 2, 3, 7. Right, and then this could be 4, 8. This could be a 5, 7. I forgot to check these actually. Yeah, the line is not here. The line is here between the boxes. So now I want to double check this one. 2, 4, and then I said 1, 5. Okay. I might have to just recheck all of them. 3, 6. I used the 6 there. And we need a 4, 8 and a 5, 7. I'll do it like this, I guess. And then the 4 there goes here. That's fine. So this is 3, 9. That's fine. We're still fine. Still fine. And this is 1, 2, 9. Okay. I think that is fine. 1, 2, 9. And then a 5, 7 here. Ah! 5, 7, 8, 4, 3, 9. What is this? We've got 4 groups of 2. That's it. That is it. I knew there must be something else. Yeah. So, how many different ways can I do 12 in 2? Not enough. So 12, I can just cross out. Good. 11, I might be able to do. 5, 6, 4, 7, 3, 8, 2, 9. That is possible. I'll check it again with this in a moment. 13 is 6, 7, 5, 8, 4, 9. That's only 3 again. Okay, it has to be 11. Okay. We got it. It has to be 11. Because if it's any bigger than 12, then there's only going to be 3 or 2 options. There's not going to be 4. Okay. And then what is the one option, that the one letter, the number that isn't in an 11? It's 1, because we can't have 1 and 10. Okay, yeah. And then these are going to be 1 and 2 in some order. These are going to be 3 and 5 in some order. So 11, 28, and then 15 left. I don't know in what order. That would be 5, 4, 3, 2. We can't have 2, so we can't have 9 there. So we can't have 6 there. All right, this is going well. It's going well. 1, 2. Okay, so we cannot have a group of 5. We have to go here. Then we can't go there. We have to go here. We can do this. I'm trying not to have 2 of the same color in a row. Well, yeah, whatever. And I'm trying to make these lighter because it's a little bit hard for me to see. All right. I can almost do it. I can almost do it. I'll leave that. Okay. Oh, I think I can do it. Yes, I'm going to do it. I'm going to do it. Because I want to. Alright, okay, I can see better. Anyway, that's 11 plus 11. Whoop. Let's not exit out this time. 11 plus 11 plus 8 is the maximum again. Do I have to do the maximum here? Can I just do 7, 5, and 2? This is going to be... Okay, okay. I can do this. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 5. And this has to be a 1-2 pair. This can't be... Well, okay, and then this is a 3, because it's in the same. 3 and 5. 3 would go with 6. All right, we're going to do this real quickly. Real quickly now. Are we? Probably. But I got distracted. What was I thinking? I had some sort of idea. I'm going to need 3, 5 in these. And 1, 2 in these. Okay. And this has to be 4, 8. Can't be 1, 2. It could be 2, 4. Oops. I meant to do that differently. 2, 4, 8. Could be 2, 4 or 4, 8. 2 can't be there. Okay. I don't know if this is useful. How many different ways can I make 11 with just 3? There's probably a whole lot. Not a ton. Yeah, okay. So that's good to remember. I can't have any 9s. I'll need a 9 in one of those two. The problem is each one is a different amount, so I can't automatically go, oh, now 9s can't be in any of these. Well, they could be in these ones. Okay. So that is 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so there's an option for everything. But 9. Oh, wait. Oof. Good. It doesn't go there. This cannot be 5, 6. It cannot be 3, 8. It cannot be 2, 9. It has to be 4, 7. Okay. Alright, I believe this is going to start working. 6, 8, 9, and the other 3. And 6 is not in this one. I could do that one too. That's got 4 things. So 3, 5, and 1, 2 are both going to be... So that's 15. If it's 7, 8, then I can do 9, 2. Okay, so that's one option. I can have 7, 8, and I'll have 9, 2 here. would be 1, 4, 6. All right, so 7, 8, 9, 2, 1, 4, 6. Or if I do 9 and 6, and I can do 4, 7 in these two. And then how would I? Okay, that would be a deadly pattern, but oh no, actually not necessarily. If I do 6, 9, 4, 7, 1, 2, 8. That doesn't really help me. Okay. You 4, 7 or 2, 9. Except this can't be 2. So this can't be 9. And if it's 2, then we can only do 1 here. It'd be nice to disprove that. I don't think I can because, well, it would be nice because it means there's a 4 there and then I can do something here. Where can I put the 2, 9? I just said can't be here. I said 9 can't be 2 and it can't be 2, 9. Okay. So there's only 2 options for the 2, 9. Still can't do anything. What about this 11? Oh, we can't have 4, 8. There we go. So we're going to need 2 and 4. And then 2 and 4, we get 5. How exciting. And we get 5 and 3 and 1 and 2. Okay. There's 1 somewhere up there. There's a 3 and 5. So 1, 6, 8, 9. Okay, I won't do that yet. 6, 7, 8, 9. Be 6, 5. That doesn't work. 7, 4. Okay, that's the only option. Wow. Because 11s and 2s have a lot of options, but it can't be 9, 2 because of that. It can't be 8, 3 because of that. And it can't be 6, 5 because of that. And then we have all those numbers there. So 7 is the option. 4, 7. How can I do 3? No, that's easy. Just don't use the 7. And then I've got at least 2 I can still put here. Okay. Now, I think these have to be 6, 8, 9. Oops. This can't be 9. So it has to be less than something. But yeah, because the smallest these 2 could be is 15. We figured that out with these 2. The smallest they could be is 15. So 6 and 9. And this couldn't be 6. Oh, it's either 6 or 8 and 9. I think that's the only possibility. Right? If it's 6 and 8, if I kept the 8 there, 6 and 8 is 14. And 25, 36, and then I can't get to 9 in here with just 2 numbers. Okay. There we go. And that's going to be nice. You can't have 9 here. So 9 is here, which means it can't be here. So we have to have 2 and 9 in this group. Okay. And then that means we have to have 7 and 8. Okay. and then 1, 4, 6. One, 4, 6 means we can't do 4 and 7, so we have to do 9, 2, 1. See if this is 6, 9. Then we need 8 here. If it's 8 and 9, then we need 6 here. We can't do that, so it has to be 6 and 9. Mm. 4, 8, 9 can't be here. 9 has to be here. Uh-oh. Uh-oh. Oh. No. It was going really well. Let me go back just a little bit. That's not right. Oh, there's... When did I do that? When did I do that 5 up there? Let me just delete one of them and check. No, still something wrong. Okay. Well, we can still do this. What I did was here, but now I don't have a 3 there. Okay, so it could be either 7, 8, and 3 or 4. Yeah. Okay. Well, we did figure this out. So 9 has to be here. Okay, that's cool. Great. 8 and 3. So 3 has to be here. Okay, I think we're going to do something similar to what we just did. It has to be at least 15 with those two. So we're going to make it 16 plus 11 plus 11 is 38. And then this needs to be 7. So this can be 1. Oh, and there is a 5 there. Ooh. Two has to be in one of those. Oh, 1 has to be here. Okay. Can we do 1, 2, 8? Possibly. One is going to be here. One is going to be here. It can't be greater than something. In this column, we can't have 1, 2, 3, 4, 5. Can't have 6, 7, 9 in the row. I can't see my mouse today. Yeah. Getting close. 6, 7, 9. Oh, yeah. 1 can't be greater than another number, and the 9 can't be smaller than another number. Maybe I need to use the keyboard shortcuts. I never remember which one is which, though. So if I... Yeah, okay. I'm done coloring, so I'll use those two. We have 9 here. Okay. Oh, yeah, I did get a 9 there. So 9, 2. Oops. 9 and 2. So it can't be 6 and 9. It has to be 7 and 8. And then it has to be 4 and 6 and 4 and 8 and 2 and 9. Yeah. Oh, and 9 can't be here now, so it has to be here, and it has to be on one of these two things. It's probably here, but it could be 8. And then that means 9 here. Okay, we're gonna be done in 2 minutes. Let's see, 48. Oh yeah, let's get it done before 50. Okay, 6 or 7 in this row. Whoops. No, now I'm not gonna make it. Now I'm not gonna make it because I made a mistake. Now I'm not gonna do it. Maybe. 7, 8. So it can't be 5. I said I wasn't gonna do that. I was gonna do 4, 6 in here also. Interesting. I'm going through numbers. We got all of the 1s. We got a lot of the 2s. Okay. Okay, 4s. Got a 4 there. Fives, come on. Can't have a 5, 6. Can't have a 4, 7, can't have a 4. This is a 2, 9. Okay. 2, 9. 2, 9. Only 20 seconds left. Okay. Yeah, I am not that fast at typing. 8. 3, 5, 7, 3, 5, 7. Not going to get it yet. Oh, we could do it 8, 6 here. So that is 7 and 4. We need a 5, 6 or a 3, 8. See, I can't prove that yet. All right, let's keep going. 6s. 7s. 7 has to be here. 7 has to be here. One, 2, 3, 4, 5, 8. Like I said, it might be an 8 there, and then 9 there. Got all the 9s. Don't know about the 8s yet. We have an 8 up here. Okay. Yeah, okay, so it's either going to be 8. Oh, okay, it can't be a 7, 4. What was I about to talk about? Hang on. I was going to say something, but there's 4, 6, 7. Okay. Three, 5, 7, which I talked about, but then didn't put in because I saw something else. I think I'm just a little too tired because I'm putting everything in, but now I see there's a 4, 5, 2. I can't see how to do 3, 5, 7. Or can't be 7. This can't be 7. Okay. And then that should get me all of these up and downs here. It should give me 4 and 6. Either 6 and 5 here or 6 and 5 there. Don't know yet. Okay. It didn't give me all of them. Is there anything I'm missing? Because it looks like it's almost, first of all, check. Yeah, okay. It looks like it's almost a deadly pattern with all of these. 4/3, there we go. Oh. 5, 5, we need the 5. 6 here, the cheese is on 6. Okay, it's cheese, not a cupcake. And then 7, 8, 3, 5, 7, 4, 6, 6, 7. Okay, yeah. Oh. Experiment completed successfully. Cells visited 41. That's a lot. Black crowds eaten 3. One-way doors used 1. Finks displayed caution around the unfamiliar one-way doors and correctly identified those that should be avoided. I mean, okay. Black crowds consumption remained optimal. Oh, did we eat all of them? Experiment 5 to go ahead next week as planned. No. Okay. It said optimal. I mean, maybe I snuck my right paw out to grab that as I ran through, but I couldn't have gotten that one. All right. That was rat run number 4, and now I'm only 2 behind Simon. So, yeah, we'll continue these later. So yeah, stay tuned for the next one.